Figure shows three equidistant slits being illuminated by a monochromatic parallel beam of light, and let BP0 minus AP0, that is the path difference between BP0 and AP0, is given as lambda by 3. Show that in this case D is given as 2 lambda capital D by 3 ka under root. Fine. Now first of all, let's say the ray goes from here, another ray comes like this. Alright, so the path difference, that is a delta x, will be given by BP0 minus AP0, that is given as lambda by 3. So the path difference can be written as d square small d square under root minus of d, that is equal to lambda by 3. Alright, now I can write it as d into 1 plus d square by capital D square to the power 1 by 2 minus d is equal to lambda by 3. So by binomial expression it can be written as d plus d square by 2d minus d is equal to lambda by 3. This is calculated by using the binomial expression. So this d and d is cancelled. I do have the value of d as 2 lambda capital D by 3 to the power 1 by 2. That is the answer for my first part. Alright, in second part, show that the intensity at point P0 is 3 times the intensity due to any of the 3 slits individual. Fine. Now first of all, the BA are interfacing at P0, so I do have the path difference over here, so I can calculate the phase difference. Fine, let's say this is delta phi 1, so it will be equal to 2 pi by lambda into path difference, that is lambda by 3. So the phase difference comes out to be 2 pi by 3 1. Fine, now I should calculate the path difference or the phase difference due to CP0 and AP0 interference. Fine, so path difference can be written as CP0 minus AP0, that will be equal to D plus 2D, D square plus 2D whole square under root minus of capital D. Fine, it comes out to be D square plus 4D square plus 4 capital D into small d minus D under root, or else I can write the same very equation by using the binomial expression as d times of 1 plus 4d square by capital D square to the power 1 by 2 minus d. Alright, now this equation can be written as, by using binomial expression, it converts out into d plus 4d square by small d into d. Right, this d and d get cancelled. Substituting the value of small d square, that is this one, I get 4 into 2 lambda capital D by 3 into capital D. So it gets cancelled, it comes out to be 8 lambda by 3. This is my path difference. So the phase difference, that is delta phi 2, will be equal to 2 pi by lambda into 8 lambda by 3 again. So it is equals to 16 pi by 3, or it can be again written as 2 pi by 3 because both are in same phase. Now one thing to notice over here is that the interference of AP0 and BP0 is creating a path difference of, is creating a phase difference of 2 pi by 3 at the point P0, and the phase difference that is created by AP0 and CP0 at the P0 is also 2 pi by 3. So I can say that the ray coming from B and the ray coming from C are in the same phase. Fine, and since if they are in the same phase, then the net intensity at point P0 due to B and C will be equal to 4 I0, because if say I0 is coming from 3 of them, this I0 and this I0 is in phase, so due to both of them the net intensity is 4 I0. And now I'll calculate the net intensity, that is the vector addition of this 4 I0 and this I0. So it can be written as, there will be no under root, it will be simply 4 I0 plus 2 under root of 4 I0 into I0, and the phase difference is cos of 2 pi by 3. So I net comes out to be 5 I0 minus 2 I0 that is 3 times of I naught. This is what I was about to prove, because it is asked show that the intensity at P naught is 3 times the intensity due to the individual slit, and that is what we have proved. So that is our answer.